Hi there. This video is going to introduce the topic of agrobiocultural diversity and agroecology, and is the first in a series of videos addressing this topic at different points. So we'll begin by looking at the topic of agrobiocultural diversity, and you can see that that word is rather awkward, but it brings together some related concepts of agriculture, biology, and culture, and they are in fact deeply intertwined. And hopefully by the end of these videos, this presentation, you'll understand some of those connections. We can start by just saying that knowledge of farming is fading as culture has become increasingly urbanized. Um, some of my other research, we've written about this kind of spread of urbanization and rise of an urban normative culture. Also, the biology of nature is becoming simplified, and agriculture is getting more specialized, not to mention more corporatized. And these are all connected events. So we're going to be challenging some of the current trends which we associate with, ironically, what we call conventional agriculture. And we'll be comparing that eventually to some alternatives that are out there. So agrobiocultural diversity, uh, it's interesting. There are 250,000 plant varieties with known agricultural uses, and yet less than 3% of these are actually pursued. And that's because in order to conduct agriculture using what we call the conventional model, requires a high level of specialization. And in fact, monocropping is a hallmark of our conventional system. And some of the alternatives we'll look at reject monocrop agriculture. So, in a time of uncertainty and risk, which is a topic we've dealt with previously, the Risk Society, and a lot of this inseparable from climate change and the host of factors that that brings, preserving species richness is like taking out an insurance policy. Can you imagine non-drought resistant crops going forward in the future? What if some of these 250,000 plant varieties have extreme forms of drought resistance and we're not paying attention? As the temperature goes up, as the water flow goes down, as a result of climate change, we're going to want to know about some of those plants. So, what we deem to be successful today, based on the historical track record, may not be ideal tomorrow. And there are, in fact, already many signs of trouble with our current crops faltering, not meeting the levels of yields that we hope to find. So, a lot of what agrobiocultural diversity is about is preserving uh, really seed varieties. And we can do that one of two ways. We can do that on site or off site. And this term ex situ means off site. Um, so we collect samples and we store them. And either, if it's animals, it might be at zoos. If it's plants, it might be at botanical gardens or other types of greenhouse settings. If it's seeds, we have gene banks. We can store things. If it's on site, we're really talking about conservation. So the biodiversity is preserved in its original location and habitat. Of course, the advantage of that is that ecosystems remain intact, but it's increasingly difficult to protect ecosystems. And some of the other possibilities are parks or heirloom farms, which have become um, really trendy for a lot of reasons, and we'll come back to that idea. Gene banks are, as we said, one of the forms of ex situ conservation methods. The biggest is in Svalbard Island, which is part of Norway, probably the closest we get to a North Pole on the planet. And it has the goal of collecting seeds from all plant species there are. So it wants to be a comprehensive collection. It's a vault that's deep in the ground. It's protected by layers of permafrost. But even those layers are melting as we speak, as a hallmark indicator of climate change. And what this gene bank provides is it's a resource for scientists. There's no citizen involvement or educational function here, so it's really got a technical function for scientists. And the hope is, we'll always have this vault we can go to if we experience some kind of planetary crisis, and at least we'll have some seeds that we can work with as we rebuild. In terms of in situ policy responses, we see, for instance, new policies in Africa that are geared towards supporting ancient farming and foraging methods. And a lot of that grows out of the peasant movement, which we'll say more about, but really just creating more self-sufficient food systems for indigenous people, and keeping them out of the global trade networks that may not serve them as well. And these preservation methods are built out of an immense, uh, well, these ecosystems are immensely biodiverse. Some of the last remaining habitats for many, many species of animals and plants. And this is preferable to, simplifying these ecosystems to just monocrop fields. Uh, so, once the knowledge goes in terms of how to farm using ancient methods, it's hard to restore that, right? To bring it back. Um, if we look at commercial sweet potato farming in the Philippines, we can see evidence of how giving ancient methods over to modern farming methods can lead to cultural loss. And so, with in situ, we're not just preserving ecosystems of biology, but of culture, right? The people who know how to live in these ancient ecosystems in a sustainable way. Uh, so a lot of this goes hand in hand with pro-peasant policies. Again, as I mentioned, promoting a more self-sufficient form of farming. Uh, the worldwide Via Campesina movement really pushes that as its central agenda. So along with gene banks, there's been a push to create memory banks. And memory banks involve lengthy interviews with indigenous people who have uh, within them the knowledge how to farm using ancient methods in their local ecosystems. And so really it's an oral history project where researchers are going and interviewing people and capturing their knowledge to the best of their ability. And by capturing that knowledge of old farming methods, we may actually have some clue of what to do with these old seeds if we have to dig them out of the vault someday. Right, so we can't just rely on biology. We have to rely on people, because farming is not just a biological project. It's a cultural and a social project as well. So from this, we get traditional knowledge data libraries where we're storing these memory banks, becoming a mechanism for writing down the ancient, and a lot of these are oral traditions, right? This knowledge is passed down orally from generation to generation, so we need to come up with better ways of preserving it, because once these cultures die out, so too does their record of their knowledge and their language in many cases even. So without this, the practices of indigenous people can be forgotten, but even worse, sometimes stolen. And so that brings us to the concept of biopiracy, where indigenous practices are hijacked, maybe by corporations, and patented, in which case, ironically, the indigenous people lose the right to use the seeds and the methods that they've used for thousands of years, because now they're dealing with a corporate product. And as we noted in other places, based on the Supreme Court ruling that allowed genes to be patented, allowed life to be patented, there's a legal basis now to do this, which is quite frightening. The Iowa Seed Savers Exchange Program is another example. This is coming back to the notion of heritage farms. That's what this is. And as an heirloom farm, it's devoted to promoting old agricultural practices and varieties that have been given up on. You have 24,000 rare vegetables, 700 pre-1900 apple varieties, things like ancient white part cattle in terms of livestock. And then they have interactive and educational functions that themselves act as a memory bank, informing local people about these heirloom varieties as well as the methods used to work with them. All right, we're going to continue this discussion in some other videos. Thanks for watching.